First of all, we need a special normal distribution. It is standard normal distribution, the standard one. It is very simple. When mean equals 0, in the middle, there is a 0. The center is at 0. And the standard deviation equal 1. So simply we can write it is the normal distribution 0 and 1. The first one, that is the mean, 0. And second one, it is the standard deviation. Who is this? Standard normal distribution. It's very special one. So now, first, we need the probability. So it asks us, what is the area? I told you, the area under the curve, that is the probability. So let me make a standard normal distribution here. The bell-shaped, symmetrical. Mean was 0, and the standard deviation was 1. Where do we need the probability? Left-hand side of 1.23. Left is going to infinite here. Before, we had probability function for the binomial, for the Poisson. Yes, we have another probability function for the normal distribution. It's absolutely, the function is the continuous function to get the probability. But we don't have to get the function because any kind of statistical textbook gives us a table. It is the table. Just a second. Here's a cutoff. I need them. I will post the table in MyLess Plus, so please download and print out. Please bring the table tomorrow. Every single day, we are going to use the table. Okay? Let me show you another one. Actually, the table has 2 pages. This one is the first, and this one is the next one. Okay, this one is better. Okay? So it has 2 pages. Just a second. We need the left I'm sorry. It's not here. I was wrong. It is right, right? It's not right, but left. Left one, here. Okay? Less than 1.23 based on a standard normal distribution. So let me go to the table. Here's a table. It is the Z table. You know, the Z is a stand for, it is a symbol in statistics for the standard normal distribution. It is the standard normal distribution table. Simply, we can say it is a Z table. Okay? What was the score? 1.23. Am I correct? Was it 1.23? Yes, 1.23. Let me see. Here's a 1.2. We had 2 decimal places, 1.2 and 3. Where is the second decimal place? Yeah, he did. Yeah, it's up there. 1.2 and 3. So go to the right and go down. There is a value, 0.8 0.8907. It is the probability. We don't have to use any functions. For the normal distribution, it's actually for the standard normal distribution, always we are going to use the z-table. Okay, so please print out the z-table, and we are going to use the z-table every day. So now I can answer the probability to the left up to positive 1.2 and 3. There is a probability 0.8907. 0.8907. It's good? Okay? How about the next one? Now it is right of 0.76. So let me make the standard normal distribution bell-shaped, 0, standard deviation equal 1. And it is that part, you know, to the left, lower than 0, there is a negative scores. But we had positive 0.76. So let me put 0.76 on the left-hand side. And we need a probability to the right. Why not? Go to the z-table. Now look for 0.7 and 6. What is the probability? 0.7764. 0.7764. Okay, let me take it. 0.7764. Just a second. We need a probability here, right? It's bigger than positive 0.76. Let me ask you, how much is half? How much probability will be half of the normal distribution? 0.5. How? Because the whole area was what? I told you the whole area from negative infinity up to positive infinity was 1. Half of it, 0.5. How about the other half? Here then. Half. At the mean, in the middle, we just split 50-50. Make sense? But now we need the probability here. What do you expect? Must be less than 50% or bigger than 50%? This one must be less than 50%, less than 0.5. But we found a probability from the z-table at 0.7 and 6. The probability was 0.7764. Wrong. We expected less than 50%, but we found 0.7764. It is much bigger than 0.5. What happened? How do you think? The z-table is wrong? Maybe not. I can say the probability 0.7764 is to the left. Remember, can you see this picture? Always the z-table gives us left probability. Always left. But now I need the right. How can I do? How can I take the probability on the right? We knew left. Any idea? Subtract from 1. Can you remember what was the rule of this?
Probability 0 to 1.
Complementation rule. Do you remember that? Inside, outside, outside, in. Yeah, it is. We knew the whole area is 1. We knew the left one, but we need the right one. 1 minus the probability. So 1 minus 0.7764 will be, I think, 0.2236. 0.2236, it is a probability to the right, bigger than 0.76. Is it good? Now, it is less than 50%, as we expected. Remember, z-table gives us left-hand side probability, the left tail. Okay, good? How about the next one? Between negative 0.68 and 1.82. Again, let me make the standard normal distribution. Mean equals 0. Between negative 0.68, positive 1.82. In the middle. We need the probability in the middle. Let me take a probability at negative 0.6 and 8. Okay? I told you we had 2 pages. We used this one, and now we have to use that one because it has negative value. We had negative 0.68. This one is a positive. So we have 2 pages. The negative z-score, positive z-score. So using the negative z-score, negative 0.68, we have to go to the other page. It's here. The same idea, but I told you, yeah, it is cut off here. So let me see. We had 0.06. Here's all point zeros, right? Let me say the very first one is a 0.0 and 0, and 0.01, 2, 3, 4, 5, and 6. So here's a 6. I mean negative 0.6. And who was the second decimal? 8. What is the probability? 0.2, 483. 0.2483. Where? To the left. Always left. 0.2483. Here, I mean here, 0.2483. Let me take the other one at positive 1.82. So go to this page, positive what? 1.82. We have to take 0.96, 56. Where it is? To the left again. 0.96, 56. To the left again. 0.96, 56. Did I say 9656? Okay, so now we took 2 probabilities. One was less than negative 0.68. And the other one, less than positive 1.82. But where do we need the probability? we need a probability in the middle, right? Between negative 0.68 and positive 1.82. But we found two probabilities always to the left, not in the middle, not in the right, always to the left. Any idea? How can I take the probability in the middle?
Subtract them.
How?
Take the 0.2483 away from the 0.9.
Thank you. We can take the subtraction, the bigger one minus the smaller one. Always take the bigger one minus the smaller one. Do you know why? Because any probability must be positive. So take the bigger one, 0.9656, minus the smaller one, 0.2483. So how much will be the difference?
0.7173.
0.7173 will be the probability in the middle between the two z-scores. Do you have an idea? You know, the z-table, we had only two z-tables. Both of them suggest us a probability to the left, only to the left. But even we can take the right one, even we can take the middle one. Everywhere. It's everywhere. Okay? So please print out the table, and we are going to take the probabilities as always from the z-table. But please remember, always it is on the left.